Okay, everybody. I'd like to introduce Russell McCarthy. He's going to be doing our next talk on data, using data to go traveling in time. Russell and I have known each other for over 10 years. We've spoken at lots of events together, but I'm going to let him talk about himself because he's much better at that than I am. But this is a really exciting product, and we've been working with this with a number of clients, and I'm really excited to hear what you've got to say today. So I'm going to turn my camera off and pass it over to you. Thank you.
Fantastic. Thanks, Anne. Hi everyone. So I'm going to crack on because this is a 45-minute to an hour presentation that I'm going to try to do in half an hour. So I'm going to speak reasonably fast whilst also trying to cover all the topics. So as Anne said, my name is Russell McAthy. I'm CEO and co-founder of Ringside Data. You can find me on all of the different social networks under the Rusty Bear. And there's a few of my loves and dislikes there. I'm not going to talk pretty much about Ringside at all. We're a marketing data platform, and go to our website, which is ringside.ai, to find out more information. But we're going to talk more and about a topic that I really like, which is Back to the Future. It's a fantastic film. I hope that everyone who's watching has seen it, because we've shoehorned the whole of this presentation around the premise of these three films. So my favorite one is Back to the Future 2, but we're going to talk and put the context of marketing data around Back to the Future 1, 2, and then we're going to touch on Back to the Future 3, which is obviously the worst film. So when we talk about Back to the Future 1, the whole principle of the data that we have about a user, we need to understand in the context of a timeline. And the timeline in a multitude of different films is complicated, but as you can appreciate, that is something that is discussed a lot about Back to the Future, is what timeline are they in? How is that impacting the things that are happening in the future? But more importantly, what can they know about what do they know today, and how does that impact what they've got and what information they have about the past? So there's a few other films there that if you've not watched them, it's worth having a look and seeing how the timelines work. But when we put the context of a customer journey together, which is quite complicated in the sense of it's not just a single visit, a user has multiple different interactions within a customer journey. And it's not just the final thing we need to look into, but the very important thing is it's not just the visit itself, it's what happens within the visit that we need to take into consideration. So we look at micro conversions, and micro conversions are similar to the events that you would have in typical UA, or actually where Google Analytics has gone with GA4 that Ed was just talking about. And we need to put a visit in the context of what that means to the customer, because the customer doesn't think in visits. They think as the actions that they partake in when they're moving from not knowing anything about a brand all the way through to actually understanding the brand themselves. So it's not just a single visit that we need to look at, it's the full timeline itself. Now, the problem is that we don't want to look at an individual, we want to understand this information in aggregate. So a user can go through the first three stages here as they go through those first three visits. But for a second user, they might have a very different fourth interaction and fifth. And another user will have very different interactions on that journey. So what we need to do as marketers is have, and at least have the understanding that as much as there is consistency in some user journeys, there is complexity and differentiation as that user progresses through that process. And that's what we need to have an understanding of. Now, what is actually quite, this is why I love using Back to the Future, is the initial sort of context of this conversation is quite easy to understand, that users have multiple touch points. But actually, what we're trying to do here is say, how much value does an individual visit have? And what is the interaction that we can do as a marketer to change something within the past in the sense of what we're doing to impact the future, which is the Back to Future reference. So One of the things we can do that's really easy is to start forecasting moving forward. And the most basic way to do forecasting is run rate forecasting. You take some of the context of the past in a reasonably high aggregate, and then you use that to predict what the future looks like with the assumption that nothing changes that you haven't seen before. So one of the ways that we've shown this for brands, and this is a screenshot from about 4 or 5 years ago, where I was working with a brand. So we were just using run rate to show what is happening in your current data and how you can use that to infer what potentially might happen in the near future. So what you've got here is for PPC data is you've got the impressions this year and the impressions last year. All of this data you can get from the Google Ads API. And then you can just plot those together. So you have a variance in your year to year. You've also then able to use that run rate and say, if we were to be the same percentage up year on year that we've seen for a period of time historically, what does that look like in the coming days, weeks, months, depending on how you're looking at this? And then you can compare that against something like click-through rate. So every graph should have a volume-based metric and then a calculated-based metric. So here we've got the volume-based metric being impressions and the calculated being CTR. And we can then see what our click-through rates are year on year and then plot those against each other. So we can then see what those variances are. Now, what this ends up is a picture where you're not just going, what's our week-on-week number, what's our day-on-day number, which are completely pointless from a metrics perspective. The important thing here is to look at the trend over time and how that trend can change what you're going to go and do about the next few weeks. So we can just see here that the current week, so from June 2020 data, you can look at this and go, we've got the ability to say, that week is an outlier. We've not seen that type of behavior before. If we see that again next week, we are forecasting that this is the output that we would see. And what does that do to what you're going to go and do tomorrow and the coming week's worth of work? You can do the same for things like click conversion performance, where you compare clicks, which is your volume-based metric, through to CVR, which is your the value-based metric or calculated-based metric. So it's good to see what's going on, and then you can start to talk about the future instead of talking about the past. Again, shoehorning Back to the Future into this conversation. One of the issues you have with anything that is basic run rate based forecasting is that year-on-year trend data is not necessarily indicative of performance. So you have what is obviously from this data an outlier in the previous year's data. You can't actually necessarily use that as a fact unless it's something that you think will also appear this year. So you can build things for reach performance, which is impressions and CTR, click performance, which is clicks versus CVR, conversion effectiveness, which is your CPCs and your or CVR versus your click numbers, cost efficiency, which is CPC versus the click volume, conversion value efficiency, which can be total revenue against cost per acquisition, or cost revenue per acquisition versus total sales. There's a multitude of different ways to answer those types of questions, and it's highly dependent on the brand. So trying to move this slightly more advanced, so taking away from run rate forecasting, there's Facebook released their profit algorithm, which is similar to ARIMA, which is a time series based prediction methodology that you can use R to calculate. Now, this is actually super simple to actually do in R, even if you've got zero experience of R, because they provide you with all the code. You just have to plug the numbers in, and then it will output a forecast. There are a few issues here. One, if you've got limited data. Two, we did something at the start of the pandemic for a client, and obviously the growth that they saw at the start of the pandemic is not just going to go off into infinity. I've just seen your question, Anne. So R is a programming language that's specifically built to deal with statistics. or at least mathematical calculations. And it's used by a lot of data scientists or statisticians to calculate and visualize the output from data. So it can connect to the majority of the data storage platforms, and you can run specifically queries written in R on that data set. And so Facebook released Profit, which is at facebook.github.io Profit. And you can go and find out more there. I'm not personally the biggest fan of this. I much prefer the ARIMA methodology, but because that takes into consideration a lot more factors, but we'll come to that later on. So now that's the more basic things. I appreciate that if we're talking about R, it's not necessarily the most basic, but that's the using what we know in the past through to infer and change the future, which is Back to the Future 1. So now we go to Back to the Future 2, and what we need to understand as we design user journeys is we expect users to follow a set path. Unfortunately, my presentation is a PDF because this is a very funny GIF where there is a hamster that climbs over the top of the maze rather than going through the maze itself. Unfortunately, I don't think that will work in this presentation. But we design user journeys as marketers, which the customers really don't care about. We, as a customer, is not going to, on an e-commerce website, specifically go from the homepage to a category page to a product page, add to basket and go through. The concept of a funnel in that sense doesn't work anymore. The same as what people previously would look at in, say, Google Analytics or Adobe, where you had the path to conversion funnel. That doesn't actually make sense as a data set. And it also is not good to educate people on how consumers actually engage with your website. So let's go back to that consumer journey. Now, this is a single user's journey where that person has visited the website multiple times. What do we want to actually understand from this? Well, firstly, we know that not every visit is equal. So a visit where a user did certain things is going to be worth more to that user at convincing them. So that's where we want to calculate the propensity change that individual visit has contributed towards. Now, what I mean by propensity is two things. One is, what is the probability that that visit is going to drive a future conversion? And speed. So how quickly will that probability factor contribute towards a future conversion? So there's two elements behind that. And so one of the biggest factors in every algorithm I've ever worked on this is what that user does within that visit. It's not what channel they came in on. It's not how long they spent on the website. It's the micro conversions of what they did when they were on that visit. So that could be that they've done a site search. They've viewed a certain number of different product pages. They've viewed a bunch of category pages. They've added items to their basket. They've viewed blog content. There's a multitude of different micro conversions where we know that not every single visit is equal. Now, as that user goes through, certain pages and certain types of interactions will appear multiple times, and certain things are going to have more or less value in the ultimate conversion journey, where we're saying how likely is it for that person to convert, all the way through to the final visit in this conversion journey where the person has purchased. Now, anyone in the UK noticing here will probably see the Honey logo, and that is effectively typically known as a bit of a stealer, in the sense that they appear very at the end of the conversion journey. They're an affiliate network that appears as a visit that happens right at the end of the journey, because that's when the user is in the basket, and Honey wants to take credit to say that user converted with our discount code and therefore give us the credit for that conversion. Now, pretty much every brand that I've ever worked with doesn't like those types of affiliates because they effectively steal the conversion away from the other activity. However, Honey would come along and say, well, that person wouldn't have converted without the discount code being there. That is the classic argument within the affiliate space. And that's something that what the data set where we have for this user going back 4 or 5 visits is going to show us the likelihood of that person purchasing, whether that honey visit appeared or not, because we will have examples of similar journeys where we have all of the similar data set where they didn't convert on honey. And that's what we want to look at from a data perspective. So as I was just saying, there's many layers of complexity here, just like Biff's Casino. Again, shoehorning, I'm unapologetic on that one. Because every visit is made up of multiple page views. We want to understand the value of each one of those page views. We want to understand the device they're on. We want to know their location from a city perspective. We want to know where they actually completed that visit, what day of the week, what hour of the day. There are hundreds of different factors that we want to put into the context of a user journey in a timeline that allows us to say, what are the elements, what is impacting the propensity for that person to convert the most, all the way through to the least, and then we can start to power up our changes that we can make in the organization to do more of the stuff that works and increases that user's propensity to convert, and less of the activity that doesn't. So as I was saying earlier, there's a ton of different types of micro conversions. You will need to define these for the website. This is something we do with our brands that we work with. And there typically would be somewhere between 40 and a few hundred different types of micro conversions. Some of them, such as product pages, would just be a product page where you would also store the product details against it, like the SKU, where that person came from, what list it was come from, etc. Some of them are a little bit more prescriptive. So just like the sports almanac, we have all of the answers. So let's actually put machine learning on top of this. So once we have that visibility of a complex customer journey, we've got the answers, let's actually overlay something complex on top of that. So just as my business partner, Ben, loves this slide because he just made this with my face on and likes to call me an idiot. But the principle behind this is I'm not going to explain machine learning in the most complex things. So any machine learning expert in here is more than welcome to call me out, and I will put my hands up and say I'm not a machine learning expert. However, I'm going to try to explain how the machine learning works from a conversion journey perspective. So the first thing we need to do is define an endpoint in a conversion journey. Now, this isn't a user level. This is a conversion journey itself. So e-commerce is the one that we're going to use the example for today. But in insurance, this could be a quote and an insurance policy happening. It can be a new customer record in lead gen. There are many different types of macro journeys. But if we talk about an e-commerce conversion, that is someone buying from that brand. So people may buy multiple times, and those journeys can be made and split up over multiple different macros. But the point being here, a macro is when a conversion event happens, and a macro journey starts right at the start and goes through to when that macro has been completed. So what you've got on the top here is you've effectively got 6 interactions that have happened with a macro conversion that's happened right at the end. Sorry, Anne, are there commonalities between sites? Are there certain behaviors that tend to result in a macro conversion across a number of different sites? So in e-commerce, they're pretty much a macro conversion is an e-commerce transaction. And an e-commerce transaction starts its own then new macro journey, because it's the whole point of understanding a journey is saying what are the factors that make that person more likely or less likely to convert again if it's their second conversion. In lead gen, you could have a lead that happens, which would be its own macro conversion. And then you might have that lead turn into a conversion much later down the line. And then you have 2 types of macro conversion for that brand, one that spans the entire journey and one that spans up to the lead itself. And anything that we've got data-wise happens before the macro conversion. So that macro conversion timestamp is the end of that macro journey. And all of the visits, all of the phone calls, all of the store visits, all of the micro conversions, all of the page views are within that macro journey. And that's what we want to show the machine learning to go, here is everything that we know could impact a conversion journey itself. And then what we do is we show it everyone. So we go, okay, here are all of the interactions that were successful, but here is everyone that's ever visited the website, who has ever done anything with the website, with the call center, and all of the data that you hold. And it then learns how successful each one of those things are towards driving a macro conversion. Now, what we've got here are people who are not yet successful, in the sense that none of these examples here have completed through to a macro conversion. But here, there is an example where it's identical channel makeup and visit count of the one above, but that last visit has now become a macro conversion. So what this will show is the variances between these journeys will give a really good indication of what's important and what's not important at getting someone through to a macro conversion, which helps answer the probability and the speed to conversion that calculates up to propensity. So there's a ton of stuff we can show the model. Position, journey, device information. I've written them all here, and I'm not just going to read off a slide. But the complexity here is actually a ton of different micro conversions. So you have all of the different micro conversions in the sequence that they're happening based on how long they are before the macro conversion, and all of those things, plus all of the stuff around here, plus a ton more, goes into that machine learning. And we basically show the model, this is all the things that could be impacting it. Now you train on that data and bring back. I'm going to answer questions as I go along because they're probably quite relevant in here. So John asks, how do you compensate for the data being skewed by historic bad, as in last click marketing and advertising activity? What prevents this from just reinforcing those kind of tactics when they're perceived to work? So that's exactly what the model will see, is it will see when those journeys are working, but also when you're showing the model the full journey, the last click activity will only be the last interaction. And if that activity appears as well outside of last click, in the sense that it happens a lot and those people don't convert, then it will train and see that data and feed that back, because those visits are going to get lower values, and the visits that appear in the same place but actually contribute towards future conversions will get more value. So it's basically showing it everything that actually is going on, and then it will output, which I think helps answer the accuracy question. So how do we know that this model is accurate? So I'm not going to go too in depth with this section, but basically one of the outputs that we show clients is how accurate a model is. So if we were able to predict whether a person will convert, so we have a training set of data, we then show and predict whether those people will convert, what their propensity to convert is. So you say how likely it is for these people to convert. If we were to have a toss of coin, in the sense that we are 50% right just because there is a chance of everyone converting or not converting, then you would have a 0.5 rock orc, which is the area under the curve that's created here. In this example, we have an 89%. So when we predict that someone is going to convert, we're effectively saying that when we correctly say they're going to convert, we're 89% correct. So this is another client's example here. So when we predicted a macro conversion would happen, did it actually happen? And 78% of the time it did, and 22% of the time it didn't. When we said that that person wasn't going to convert, 80% of the time they didn't convert, and 20% of the time they did. And the whole goal of having machine learning here is that it learns when it gets it wrong and when it gets it right, and then will improve that over time. So what you're trying to do is, one, increase the accuracy of this. But if you think about the majority of people aren't going to convert on a website, so you've got a 1% conversion rate in e-commerce, maybe 2%, that means that 98% of people aren't converting in that one visit. What we're doing is we're taking that data and looking over a longer period of time and saying, what is the prediction that that person will convert in the next 30, 90 days? And say, if that person potentially is going to convert, then they're worth more to us, and we want to understand what value they bring in that longer journey. So we can then show this by different devices for different types of conversion journeys. I'm conscious of time because I know Anne's going to come and interrupt me in a second. But then you want to play that out onto a single visit because it's not all about the last visit. So what you then are able to say is, instead of giving 100% of the credit to that affiliate visit that happened right at the end of the journey, which we can see, obviously that user got into the conversion stages, they were ready to purchase, then they went and got that discount code. What we've been able to do, and the machine learning has just taught itself to understand that type of behavior, is it's given a significant chunk of that conversion, which is 80% of that conversion. So that person's gone from visit 5 having 1 conversion associated with it and £76.50 to only 20% of a conversion and £15.30. Now, that isn't blanketly given a 5-touch journey. It's a combination of what micro conversions did it happen? How long was it between the previous visit and that one? What micro conversions? What time of day? What device? What channel? There's a ton of factors. It's not just, it's the 5th visit in a journey. And so what we then do is, if we saw exactly the same journey, but it was only the last 3 points, so it's paid social, organic search, and affiliate, we want to still have the context of the affiliate taking less of a value of that journey. It is irrespective of how many touch points happened before it. So I will then just finally touch on Back to the Future 3 before Anne tells me I've got 2 minutes left, and talk about some old school logic of data analyses and how you can overlay that into more modern data sets. So one of the things that we've shown clients is using things like box plots. You can do violin plots now, which is just a pretty version of this that shows where the volume is. But what this will give you is here you can look at click-through rate and the variances against the average. So what we've got, and if we use the example that's third from the right here, you can see the grey box, the grey circle, which is actually the 50% mark, which is the mean, is going to give you what your current mean CTR is. Then the red dot is the current CTR on today. And then the green area, the dark green area, is your lower quartile to your upper quartile. So what is the typical range of CTR that you would expect to get for a period of time? And then the lighter green is your proper lower quartile value and your upper quartile value, so the maximum values of that. So if your current CTR is in the darker green area, that means that you're very close to your typical CTR for whatever period of time you're looking at. If you're in the light green, you're still in an expected range, but it's worth keeping an eye on. If you're outside of the green area, so if you take the sort of 4th and 5th in from the left, there's something for you to look at here. So one of the things is you can use more old school logic, like they did in the Wild West, shoehorn again, and use the current data set to look at things like click-through rate and other metrics like that. So firstly, what you should be doing already for Back to the Future Part 1. So get reports and dashboards that look at trends, not just week on week, and use things like run rate and have a look at things like Facebook's profit. If you are looking towards profit, also look at ARIMA-based forecasting. You can do that reasonably easy nowadays. What you should do in the future. So use machine learning to understand the full value of a journey. So that is typically what people talk about when they look at more complicated marketing attribution models. And then don't also forget about old school analytics and analysis, where you can use things like box plots to really help and visualize the changes against expectation for a period. You can look at means, standard deviations to actually get a decent logic engine to base your calculations on. And that normally has a picture of a DeLorean on it.
Thank you, Russell. You sort of answered my question in the next slide, which was what I was trying to get to was, if you know that you've got a conversion, a macro conversion on an e-commerce website, is there certain things that often happen when you compare one e-commerce company to another's website? So is it, duration, number of product views, that sort of things? Is there any what I was asking for, was there things that are common that you often see happen in sites that have conversions, so that if you know that you're not doing that, then it's likely you're not going to get the conversions that you might expect to.
Yeah, so I think a lot of this is driven by the marketing strategy and the differences in everyone's marketing strategies. So I've worked with e-commerce brands where they direct a lot of traffic deep into their site, whether that be that they've got great SEO down to product pages, or they've got their PPC, Facebook ads, Instagram ads directly into a product page, or they do it up to a category page. Now, those two are very different in the sense of what value a product page has in an algorithm changes dramatically based on the context that a user has when they arrive at the website. And so every separate website will have an add to basket is a very high factor towards a future conversion. But the value of a blog, for example, can differ based on the quality of the blog or the quality of a specific article. So there's commonalities that are obvious, such as when you get through to stages within the conversion flow, they are significant impact factors in an algorithm. However, things like viewing a product page, I've seen be negative because they've driven so much traffic to a website, it doesn't necessarily turn into a conversion more often than it doesn't. And so that isn't always a positive factor. In other sites it is.
Yeah, I mean, we've seen 80-90% bounce rates on some shopping ads campaigns because they've gone through to a landing page and bounce. But the interesting thing we've been seeing a lot in the last data, and I know it's not particularly related to your platform, so it's more indirect evidence, is how if you increase the activity around shopping, you actually get a lot more organic and direct traffic. So it's having a brand awareness impact as well, which I wouldn't have expected previously. And I've been tracking that on a couple of sites to see what the impact is. So, but thank you very much, Russell. That was really, really helpful. And I'm not sure whether I think we're going straight into Jono. No, we've got a break for half an hour. So we've got a half an hour break. So I'm just going to thank Russell very much for his really brilliant presentation. If anybody else has got any questions, please ask them in the chat. As you know, we've got two things we're trying to do today. We're trying to raise money for the local charity. So I'll just bring that back up. So if you haven't already donated, please do. And then the other thing that can help with that is I'm also, for everybody that completes our survey today, we're also donating an extra £5 to go for the survey. There's about 50 so far, so it's a couple of £100 already. But if you please fill in that as well, that would be amazing. Love to hear from you. So I'm just going to put that one up as well. So we'll see you in half an hour. I'll be back about 25 past. So if any of you go and grab a cup of tea, and we'll see you very shortly. Thanks a lot. Thanks a lot, Russell.